Hi there. So this is where we left off last time in trig part 2. So remember, we can now think about the trig functions where the inputs for the 6 trig functions are angles, either in degrees or radians, and then the outputs are ratios of x, y, or r. And remember, r represents the distance of a point from the origin, because if we were to think about an angle theta, just draw a quick picture here. So let's say that we have an angle theta that's in standard position. So it starts on the positive x-axis and then rotates. I'm going to have it be a positive angle theta rotating in the counterclockwise direction. And let's say that it terminates somewhere in quadrant 1. Could terminate anywhere though in the xy plane. So if this is the angle theta, now the terminating side of theta passes through infinitely many points. So I'm just going to pick a point and call that point x comma y. Now the distance of that point to the origin we call r. And to help you with remembering that, think about it. If we were to draw a circle that was centered at the origin and passed through the point x comma y, r would end up corresponding to the radius of this circle. And since the radius, remember in the unit circle, the radius would be 1. All of the points that lie on the unit circle would be a distance of 1 from the origin. And that's why we're able to use the unit circle as a reference, because r would be equal to 1, meaning that sine of theta is equal to y, cosine of theta is equal to x, and so on. But we can extend, and if we think about the terminating side of an angle that's in standard position, passing through a point x comma y, we could still come up with what the ratio of sine, cosine, tangent, or any of the reciprocal trig functions are for a particular angle theta. And that's what we're going to be practicing now. So we're going to think about an angle that passes through a specific point. So like the point 84 is a point in quadrant 1. So I'm going to draw the picture. I think it's very helpful to draw the picture for these. So x-axis, y-axis, and this is just a sketch. I'm going to call that 8 and that 4. So here's the point 8 comma 4. And then this would be the angle theta. Theta would be starting on the positive x-axis and then rotating in the counterclockwise direction and terminating in the position so that it passes through the point 8 comma 4. Okay, now looking up here at these ratios, we now know x and y, but we need to figure out what r would be. So like what the distance of this point is to the origin. And going back up to this picture here, notice that if we were to drop a perpendicular and create a triangle like we did whenever we were deriving our unit circle, this leg of the right triangle would correspond to x, this would correspond to y. So the relationship between x, y, and r can be described by the Pythagorean theorem. So that x squared plus y squared is equal to r squared. And we can use that relationship in order to help us solve for if x, y, or r are unknown. So in this case, we can think about solving for r, because r squared would be equal to 8 squared plus 4 squared. R represents the distance of the point to the origin. So r is positive. So we'll have the positive square root of 64 plus 16, which would be root 80. And we can simplify that. What would that be? So thinking about, so 80, we can write as 2 times 40, 2 times 20, 2 times 10, 2 times 5, right? So 4 root 5. Oops. Yep. 4 root 5. Okay, so then referencing what those ratios are, we could say that sine of theta, and we don't have to determine what the angle theta is. You actually don't know how to do that yet. But sine of theta would be the ratio y over r, so that would be 4 over 4 root 5, which would simplify to be 1 over root 5. And if we thought about rationalizing the denominator, that actually turns into root 5 over 5. The reciprocal of sine would then be root 5 over 1, or it would be 4 root 5. Here, I'll write it out like this. R over y, so 4 root 5 over 4, or just root 5. Cosine theta would be x over r, so 8 over 4 root 5. Okay, or that would end up, if we rationalize the denominator, being 2 root 5 over 5. And the reciprocal secant, the reciprocal of cosine is secant, would be 4 root 5 over 8, or root 5 over 2. Okay, and then tangent is y over x, so we already had that information, so 1/2. And cotangent of theta would then just be the reciprocal, which you could think of it as 8 over 4 or 2. Okay. Same idea for if you have a point that's not in quadrant 1. So -1, 3 would be a point from quadrant 2. So thinking about an angle that's in standard position. So starting on the positive x-axis and then terminating in quadrant 2, passing through the point -1, 3. I'm just drawing a rough sketch of that. And technically, any angle that would be coterminal to the angle that I've just drawn would have the same ratio. But this is just an angle that is going to be less than 360 degrees, less than a full rotation. Okay, so we know that that is the point -1, 3. R, we could use our Pythagorean theorem again. If you want to pause this and try it on your own, and then you could check your answers, you can do that. So R would end up being the positive square root, kind of skipping the step of setting up R squared equals to -1 squared plus 3 squared. So -1 squared plus 3 squared. So R is actually equal to root 10. So sine theta will be y over r, so 3 over root 10, and if we rationalize the denominator, we would have 3 root 10 over 10. Okay, cosecant of theta would be the reciprocal, root 10 over 3. Cosine theta would be x over r, so x being -1 over root 10. So -root 10 over 10 when we rationalize the denominator. And then secant theta would just be root 10 over -1, so -root 10. Tan theta will be y over x, so 3 over -1, or just -3. And then cotangent of theta would be -1/3. Okay, and then these next questions are also just like, they're going to feel like the process that we use, the thought process that we use, will continue to come up kind of over and over again. I know these will feel a bit contrived, but the thought process and pulling out information, like given information, is going to continue to come up. It'll come up again in vectors, And this is also, I feel like I've seen on standardized testing, so like the SAT. But looking at this problem, so if cosine theta is equal to 40 over 41 and the terminal side of theta lies in quadrant 4, find tan theta. So I think it's really helpful to draw the picture here. So quadrant 4, and thinking about theta being an angle in standard form, so Q4 is over here, okay? And then thinking about, okay, cosine, remember, is the ratio of x over r. So thinking about an angle that starts on the positive x-axis and then rotates, we'll just have in the counterclockwise direction. And then we'll terminate in Q4. I'm just going to draw that. So this is theta. Now, cosine being x over r, that means that the terminating side of theta will pass through a point that has an x-coordinate of positive 40. Since we're in Q4, x is positive. We don't know what the y-coordinate would be for when x is passing, whenever x is equal to 40. But we do know that the distance of that point to the origin would be 41. Okay, and tangent of theta, tan theta, remember, is y over x. So we do need to figure out what y would be. And we can use Pythagorean theorem to do this. So 40 squared plus y squared will be equal to 41 squared. Y is going to be negative in quadrant 4. So the negative square root of 41 squared minus 40 squared. Okay, so y will end up being negative 9, which means that tan theta is going to be equal to negative 9 over 40. So using the given information in order to come up with what that ratio is. Not solving for theta. We don't know how to solve for theta. Eventually you'll figure out how you could solve for what theta could be. But the question is just asking us to find what the ratio of tangent of theta would be based on that given information. And you can pause right now and you could try this next one on your own and then check your answer. But we are given that tan theta is equal to negative 5/12 and that theta lies in quadrant 2. And we are trying to find what cosine of theta would be. Okay, so for knowing that tangent of theta, I just draw an angle that terminates in Q2. It's just a sketch. So knowing that tangent of theta is negative 5/12. Remember, tan is y over x. So in quadrant 2, x is negative, y is positive. So I could say that theta passes through the point negative 12 comma positive 5, since y would be positive and x would be negative. And then we can figure out what r would be, but we want to check, do we need r? Yep, because cosine is the ratio x over r. So we know that cosine of theta will be equal to negative 12 divided by something, and we need to figure out what that something is. So r will be equal to the positive square root, because r represents the distance, of negative 12 squared plus 5 squared. So what is that? 144 plus 25, which would be the square root of 169, so 13. Okay, so that means that cosine of theta will be equal to negative 12 over 13. Okay, so you're looking at interpreting what that given information is telling you so that you can solve for whatever ratio it is that you're being asked to solve for.